Okay, hi everyone. How did the practice problem go? Do you guys have any questions about them? Go ahead, either speak up or use chat. Don't be too quiet. Anyone? Okay. So before we start, as I told you, you have a homework. It's actually a simple homework, but let me make sure you all know how to get it. So I will try to share the screen with you for a second and show you where you can find it. So I think I have to go here. Okay, so you go to content. Let me go to the student view. So this is your view, I think. So you just have to go to content and you go down to homework, though that, and I wrote, those are to be handed in. So they are not really practice problems. And you open it, the homework is here. You take it, you upload it as a PDF document, not only as pictures. I want it as a PDF document. So you take it, you print it, you take it, you upload it as a PDF document into Brightspace. All right, so that's about the homework. Okay, okay, so stop sharing, go back to you. All right, so if you don't have any questions, so we can start. Let us see where we are. So last time we introduced the idea of a statement. And a statement is a sentence which is either true or false, nothing in between. So for example, one of the practice problem was, let us say n, because one of your classmates, n is not a power set of n. Is this a statement? Yes or no? Is it true? Yes or no? Go ahead. Is it a statement? And is it true or it's not true? Please. Don't make me pick. I will pick if I don't get an answer from, if I don't get volunteers.
What is that symbol that you wrote?
Oh, an element, not an element. This is from your practice. That's
Is that of a power set though? Is that
yes,
what
yes.
is? Okay.
That's it. Okay, so the question is true. Is it a statement, yes or not? If it is it a true or false?
It is a statement.
Is it a statement? Okay, true or false? And justify, of course. Anyone? Simon said, I think that's a statement, but it's not true. So Simon is telling me it is false. And somebody has, of course, why it is false.
Isn't it supposed to be the set of n instead of n?
N is a set by itself.
Or sorry, yeah.
Yeah, N is a set. N is not, it's a set. It's a set. Okay, so why this is not true? How would you justify? What does it mean something is not an element of the power set? Or what does it mean and it's something of an element of the power set? Who would like to tell me the because? Why the statement is false?
Wouldn't n be an element of the power set because it itself is a subset of
Exactly. False because n is a subset of n. Sorry, I'm changing the notation. N is a subset of n. Remember, n is a set. It's not a number. It's just a set, it's a collection of stuff. N is a subset of n. So n is an element of the power set of n. Okay, so n not in the power set is a false statement because n is a subset. So n is actually an element of the power set of n. All right? Okay. Last time we talked about statement, which is something which is true or false, but not both. And please, I encourage you to do the practice problem because those it will help you in the homework. And not only that, it help you really to understand this stuff. So we started talking about statement, which is something true or false, not both. And then we combined statement by something like P or Q. We talked about P and Q. And not P. Not P, it means everything else but P. And we mentioned the truth table of them, and let us remember the truth table. So if we have P and Q two statement, and that's from last time. And what are the truth table? One is P or Q true, and one is P or Q false, and this depends on the value of P and Q. So we had, if P is true, then we have two possible values for Q. And if P is false, we have two possible values of Q. So we write this way. P or Q is true if one of them, or both. So it's true here, true here, true here. It's false, sorry, this is F. False in one scenario. P and Q, all right? Again, false, false, true, false, true, false. P and Q is true in only one scenario. When both are true, it is false otherwise. Non-P, it means everything not P. So the non-P will have to embody in it everything that's not the P. So whenever it is true, the non-P has to be false. Whenever it's false, the non-P has to be true. Okay. Now, sometimes we have the following terminology, like you will read P but Q. P but Q. What do we mean by that? This means verbatim P and Q. So whenever you have this but here, this means P and Q, which we'll see it a lot. Another terminology that we have to know is neither nor. Neither P nor Q means what? Anybody? Anyone? Any hint? Any I don't know, intuition? What will this mean? Neither P nor Q means not P and not Q. So neither nor in math would mean not P and not Q. Okay, so this is a terminology that we will be using a lot. So, for example, suppose I introduce three statements. P, 15 divisible by 3. Q, 15 divisible by 5. R, 15 divisible by 6. So I'm introducing the statement. And my question is simple. I'm going to give you a sentence, and I want you to write the statement below using P, Q, R, those statements, and the logical connective, and, or not. Okay? So let's take the first one. Raise this up a little bit. Yeah. Okay. How can we write this first sentence using those logical connective? Not P, neither divisible by 3, nor it is divisible by 5. It means it's not P and not divisible by 5 and not Q. Neither nor is not and not. Okay. Another simple question is the following. Okay. Now I will raise this up just in case you guys are writing, whatever. Now my other question is 15 is divisible by 5 or by 6, but it's not divisible by 3. So it's divisible by 5 or 6, but not by 3. And these are the P, Q, and R. Yep, it's working. So how can you write this using P, Q, and R? It's divisible by 6 or this, but not by 3. Okay, quickly. You can say it in words, you know, in mute and say it. All right. What shall I write? Timothy Backus, if you can speak, please let me know.
I think it would be Q and R.
Q.
No, I'm sorry, Q or R.
Or R.
And not P.
Not P. What issue do you think I have with that? One small issue. Anybody? Always we have issue with that. Parentheses. Important. Okay? We have to have parentheses. Because if we don't have parentheses, you know, how am I supposed to read it? So if I have Q or R and not P, so how I am supposed to read it without parentheses? So the question means, in other words, will this and this be the same? Yes or not? What do you think? Are those the same? What do I mean by those the same? No, because is this statement true? That's what we mean the same when we're talking about statement. It means, do they have the same value? Is this statement true? Yes or not? 15 divisible by 5 or 6, but it's not divisible by 3. Is this statement true? Yes or not? Peter, no, Peter, that's the answer to the other question. Is this true? Yeah, 15 is divisible. Is this true? P is divisible by 3, which is a correct statement. So now P is a false statement. So this whole thing is actually a false statement. What about this one? Is this a true or a false statement? Quickly, is this a true or a false statement? Absolutely false, because Q is false. Q is it a false statement? It's a true statement. Why false, Logan? Let's look at Q. What can you say about Q? Is Q true? 15 divisible by 5. Q is absolutely true. So I don't care about this because true or anything is true. Okay, so the parentheses play an important role because in what sense they play an important role? If you mess up the parentheses, we're not really reflecting the correct statement. This is a false statement and this is a true statement. So whenever we're gonna write things, we have absolutely to write parentheses. So now the correct way, you guys were correct, the only thing we missed is actually the parentheses. 15 divisible by 5 or 6, but not P, which is in this case absolutely a false statement. Okay? Question before we proceed. There is one more operation we're going to do on statement. Actually, there are two more, but today I will emphasize one. So we talked about P or Q. We talked about P and Q. And we talked about not P. Now there is another one which is called the conditional statement, which is actually the one we use the most a lot in math, because a lot of our statements in math are of the form if then, if then. So I think it's section 3.3 in your book. So we're going to talk about conditional statement. Conditional statement. Okay. And before I tell you what the truth table of it and what it is, I would like really to motivate it. And the easy way to motivate it is as follows. Suppose I'm going to motivate where the whole truth table comes from. Suppose I take the following example that I always use with the student. So suppose I tell you the following. Me, your teacher, tells you the following. I give you the following statement. I tell you that if conditional statement are statement of the form if then. If you get 100 on the final exam, if this happens, then you get an A in the course. An A in the course. If then, so if this happened, then this happened. So here I am giving you what we call conditional statement. Means I'm telling you that under this condition, if this condition is satisfied, it means you get 100, then this would be satisfied. So if this happened, then this happened. So this statement is called, so statement of this form are called conditional. Means statements that involve if then are called conditional. Conditional statement means under this condition, it means this condition guarantee that. All right, now I'm gonna ask you the following questions. I'm gonna introduce proposed statement. Let P be the statement you get 100. You, it means every one of you. You get 100 on the final. And Q is the statement you get an A in the course. All right? And I'm gonna make a small table and I'm gonna ask you several questions. Okay, suppose P is true, you get the final 100. And Q, and this, the last piece is the truth of Norma Elias' statement. It means, is she true? Her statement is it true or correct? The truth of my statement. All right. Suppose the following happen. You get 100. I give you an A. Will my statement be true, yes or not? Am I being faithful or I'm lying? I want an answer. True, no problem. Okay, suppose you get 100. I did not give you an A in the course. Is my statement a true statement or a false statement?
False.
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 False, absolutely. Now, let us say you did not get a 100 on the final. So this is a false statement. I gave you an A in the course. Is my statement true or false?
It's true because you could still earn an A without getting 100 on the final.
Exactly. It's true. Because I can still get an A without having to get 100 on the final. Okay, so even if you get 100 is false, I mean, and Q is true, but my state is also true for the same reason your classmate said. Something else could have triggered to the 100. Okay, what if you didn't get 100 and I didn't give you an A? Will my statement be true also or false?
It'd be true.
Because
The P and Q don't prove your statement to be false.
right, because you didn't get an A, you didn't get 100, and I didn't give you an A. Big deal. You didn't get an A because you didn't get an A. My statement will be still true. So this will motivate the idea of P, if P then Q, that we will write it in a second. So my statement, if P then Q, is actually true if then tells me that if this condition is satisfied, then this would be satisfied. So the P part guarantee the Q part. But if P is not satisfied, the Q, I don't need it. It could be true or false. So if P then Q is going to be false in one situation only. It's going to be false in one situation if my P is true and my Q is false. It's the only place where my conditional statement is going to be wrong. Okay, so this will motivate a little bit for us the truth table of if P then Q. Okay, so let us go through it clearly. So let P and Q be two statements. It means something which is true or false. Then the conditional statement. I read it very slowly in case you guys are writing. If P then Q, that we denoted by, that's the notation we use. If P then Q, sometimes the book is using 2 arrows. I don't really care. You can use 1 arrow. If P then Q has the following truth table. So when if P then Q is true. If P is true and Q true, P and Q is true. If P is true, but Q is not true, is false, that is false. If P is false, I don't care about Q. My statement is true, whether Q is true or not. So that's the truth table of P and Q, and the motivation is exactly the one I tried basically to give you. So notice that if P then Q is false, only in one scenario, only here. So if P then Q is false only in this scenario, if P is true, Q false, it is false. Everywhere else is actually a true statement. Now, P usually, so in the statement, if P then Q, P is called the premise, or sometimes the hypothesis, and Q is called the conclusion. Okay. And the statement if P then Q tells me, if this is true, tells me that the truth of P guarantee the truth of Q. That's what it tells me. So saying that if P then Q is a true statement is intuitively telling you that the truth of P guarantee the truth of Q. That's it. If P is false, nothing about Q. So let us a little bit practice this.
So what is Q called again?
Conclusion. So P called the premise or the hypothesis, Q called the conclusion. All right? Okay, so let us a little bit take some straightforward example, and I will ask you about them. Any question before we move on? Okay, you guys should ask more questions. All right, so now my problem is the following. Find the truth value of the following statement. All right, we're gonna find the truth value. All right. If 2 is prime, then 2 is odd. If, then. So that's a conditional statement. All right, so is this a true or a false statement? So this is my P here, and this is my Q. So this is my P, and this is my Q. That's my hypothesis, if you want, and or my premise, and that's the conclusion. If this is a true or false statement, according to the truth table.
False.
False, because is this true?
Yes.
Yes. I have an issue now. Since this is true, everything will depend on Q. Q is false. That's a false statement. So that's if P then Q, that's absolutely a false statement. Now we move on. If P is a square, then, oh, sorry, I used P for two different things. So let me use something else. If T, sorry, let me write this T so I don't use, okay. If T is a square, then T is a rectangle. Now, T is like a polygon in my head, a four-sided polygon in my head that you guys don't know what it is, but something that is in my head. Is this statement true, whether you know T or you don't know T, or is it false? Back to you. So T is a polygon in my head that you don't know what it is, but that's okay. And my question is this true or false? Regardless what T is in my head. So that's an if, then statement. Okay, what do you think? Is it true or false, whether you know T or you don't? Okay, I don't see anything on chat. Nobody is unmuting, so I won't. Let's see. Before I pick up somebody that I pick up somebody that I actually don't know. So I pick up Nicholas. Nicholas Solek, what do you think?
It would be a true statement because your premise and conclusion are true.
Not necessarily. T is something in my head. Okay? So T could be a square or not a square, right? Suppose we're going to take two cases. T is square, T not a square. Is my statement true in both cases? So you're half correct, but I want to make sure you're fully correct. Is my statement
Oh,
true?
wait, it would be true because whether it's both true or both false, it's true?
Right,
Okay.
right. Because if T is actually a square, it means if this one is true, now a square is of course a rectangle. Sorry, a square is a rectangle. So if it's a square, it is a rectangle, so it is true. If it's not a square, will my statement still be true? Yes or no? Patrick, I know you're from an iPhone. Can you talk, Patrick?
I'm on the train, but it can be true or it could be false.
What? If T is not a square,
Yeah, unless
will my
I'm missing
statement
something.
still be true? Yes.
Sorry.
Anybody else can help?
Wait, if T is not a square, then T is a rectangle, then it would be false, right?
What do you think? Anybody else?
Oh, wait. No, wait. If T is not a square, then it could be a rectangle, or it could not be.
Yeah, but will my statement be true or false? Who want to pitch in? Who want to really argue whether my statement is true regardless? I am Logan. Please speak up if you can. I'm saying the statement is false because you could have. All right.
The statement is true.
Okay, let's go back to the truth table. How is if P then Q work?
It's true because your statement's true because if it isn't a square, it doesn't matter whether it's a rectangle or not. It's always going to be true.
Right, right. So my statement is always a true statement. So let me discuss that. Remember how the table if P then Q work. If my premise is true, my conclusion my conclusion true, it's true. If my premise is true, my conclusion is false, it is false. If my premise is false, regardless of the conclusion, my statement is true. Regardless of the conclusion. So whether this is true or false, it is always true. And now that brings me back to this problem. T, as I said, you don't know it, but it doesn't really matter to be. Yeah, you have to know the tables. Absolutely, Logan. That's totally under control. So T is a square. And I thought you don't know it, but it doesn't affect the answer. So if this T in my head is square, then T is a rectangle. My statement is true. If T is not a square, it means my premise is false. But then I don't care about the conclusion. It is always true. Okay, so that's really a bit confusing, but really the idea is that like I motivated, that's why I try to motivate it. If you don't get an A in your course, then my statement is true. If you don't get 100 on your final, my statement is true, whether you get an A of the course or you don't get an A of the course. My statement is always a true statement. Okay, so this statement is true regardless if you know the T or you don't know the T. Okay, now another example. Notice I have simpler one because I'm being very precise. If 2 is odd, then 2 is prime. If then, that's a conditional statement. Is this a true statement or a false statement? Okay, so this is my P, always the premise. That's the premise. That's the conclusion. My premise is what?
False.
False.
So you already know your statement's true.
My statement is true. I'm done. Okay, okay, the last one, just for the fun of it. If pigs can fly, then 1 + 1 is 3. This is a true or a false statement. That's an if, then. That's again a true statement. Why it is true? Because my premise, unless pigs can fly, I don't think they do. My premise is false. It means I don't care about the conclusion. It's always true. So if P, then Q. If P, then Q. And as I said, this is all why we study those, because all the mathematical theorems, everything has the form if, then, if, then. So if P, then Q is false in one scenario, when the hypothesis is true, the conclusion is false. That's how if P, then Q could be false. Anywhere else, if P, then Q is a true statement. Okay, so let me ask you just for to emphasize.
Can I ask a question really quick?
Of course you can ask a question. It doesn't have to be real quick. Go ahead.
So back with the square and rectangle problem,
Yeah.
because you say the whole statement is true, does that mean T has to be a rectangle then?
No.
Okay.
Doesn't have. T is for four figures, if you want. What we call this is quadrilateral. Okay, that's the only thing you know about T. You don't know whether it's a square or not a square. You don't know anything about it. But the statement is true because I broke it up. Quadrilateral, either is a square or not a square. Am I correct? So I cover all my bases here. Either it's, yeah, if it's a square, it means this is true, then this is true. No way out. If it's not a square, it doesn't have to be a rectangle. You know, that's not a rectangle. So if it's not a square, I don't care. If it's not a square, it means my premise is false. My whole sentence is true.
Okay, that makes more sense now.
This makes sense? Yeah, because I'm covering all my bases. I mean, I cannot say, if I take the cases square and rectangle, this would be, you should tell me, what are you talking about? What if it's rhombus? You know, so you have to take, when I broke my scenario, I have to break in every possible way a quadrilateral can be. It's this or not. I don't have anything in between. All right, any other questions, please? Very good. So as I said, I want to ask you a simple question and then we proceed. Simple question. What is my question? My question is the following. So just to practice those ideas. So you have three statements, P, Q, R. And you know the following. This is false. And this is false. And this is true. So you don't know them, but you don't really need to know them. And my question is very simple here. What's the truth value of that? What's the truth value of that? Is it a true or sim? Just to practice, you know, mentally.
It's true because you start with the first part and that's false. So you know immediately it's true.
Right. P or Q, that's false. Immediately it's true. I don't care. Now, question number 2, suppose I take P. Let me see, P and R. No, I don't want. Non-P and R, give me Q. Yeah. No, give me R. True or false?
That'd be
It'd be
true because
True
not
because-
P and R would both be true. So that's true. So
That's
you
true.
have to look
R
at
is
your,
true, non yeah.
so now you have to look
R.
at your conclusion, which is true.
That's true. Okay, very simple example, so you can totally get that. Now, suppose I put a Q in here and I put that. True or false?
False because your conclusion's false.
Right. This is false because non-P, that's it true. R is true. It means my premise is true. My conclusion is false. That's the only place the if-then statement is a false statement. Okay, so just to capture all the problem. Right. Part 2 is the following. Let us say I ask you the following questions. Okay. I say, let P be the sentence, the following statement. I tell you, let P be the statement 15 divisible by 5, let us say. And Q, let us say 15 divisible by 6. And I ask you to write me the following statement using the logical connective. So suppose I tell you 15 divisible by 5 or 6, but not divisible by both. Okay, sorry. So, and my question is, oh, you guys wrote a lot of comment. Sorry, Chris. Okay, so I didn't look at the chat. So if you have any questions, please write them again. Somehow I was focusing on this. I didn't look at the chat. Okay. What was the last part again? Which last part, Chris? Is it this one? Chris, please say yes or no, because I have to proceed. Okay. All right, you have it now. Okay, so this is false because non-P is true. R is true, so the AND has to be true. Q, I give it to you false. So if P then Q now will be false because the premise is true, the conclusion is false. That's the only place where the if then is false, which is very important. Okay. So now this is my question, and I ask you to write it using whatever you want. How can you write this? So it is divisible by 5 or 6, but not divisible by both of them.
So could you do, so parentheses pure Q, and then and the negation of P and Q? And then the first one,
Do I need parentheses? You have to pick.
yeah. So negation parenthesis P and Q, and
What do
then
you think?
parentheses.
Yeah.
And then it should be true, and then the statement in the parentheses on the second half is false, and then you negate it, it's true, so they're both true.
So this statement is true, right?
Yeah.
Right. Do you agree with him? Okay. Let us say another student used this exclusive or. Do you think this one is true? What do you think? Yes, the same thing. Okay, here's my question now. How do we know? How do we know? Suppose one student wrote it this way, one student wrote it this way. The idea is, how do we know that those two are actually the same thing? That's what Peter is telling me. Yes, the same thing, and I agree with him. But how do we actually mathematically verify that if a student tells me this or a student tells me that, those are actually the same? The way we're going to justify that, if you have two statements and everybody write it different way, what does it mean to be the same? Mean the same is the following. Every value of P and Q that make one true should make the other one true. And every value that make one false will make one false. To be able to actually make sense out of what I'm saying, I need to introduce the idea of a truth table. So what is the idea of the truth table? Okay, so to be able to know whether two things are the same, we need the notion of a truth table. What is the truth table? The truth table is the following. So I will put it out and then we will work with it. What is the truth table? Suppose you have a compound statement. What do I mean by compound statement? It means statement like what we're working with. It means not like one statement, 2 is even. Compound, it means 2 is even and 2 is odd and pigs can fly. So it's a combination of things. So suppose you have the truth table of a compound statement made of other statement, PQR. It's a table that gives the value of the compound statement for every possible value of PQR. So it's a table which is going to tell me what is the value of your statement when the value of its component PQR are changing. So let us draw some truth table today. Fairly easy, but let us draw them. So I'm going to go back to the statement I give. Some of you, Peter gave me this, and then I told you that. So let's see what's the truth table of a statement like that. And how do we draw a truth table? Okay. So we're gonna, can I move on, guys? Can I move on? If I don't get the answer, I move. Okay, so let's move on. My question is, draw the truth table of, so draw the truth table of P or Q and non, P, and Q. What does it mean, draw the truth table? It means draw a table that tells you the truth value of that for every possible value of your component. Now, so we have a really table here. Okay, and one column are all the possible value of P and Q. And then the rest, we'll do it slowly. Now, what are the all possible value of P and Q? We did that before. P can have two values, true or false. That's P. For every value of P, Q can have two values, true or false. So every possible value both combined can have are 4 of them. And that's really what we reflect in the truth table. So this is a true, because every time this is true, Q can have two values. This could be false, and every time it is false, Q can have true value. So this is my P and Q. I want the truth table of that. So we do it piece by piece. So first I'll do P or Q. And then I will do P and Q. And then I do non-P and Q. And then I want the and. So the last one would be the one I'm interested in, which is P or Q. So I do the pieces first, and then I will do the whole picture. Okay, so let's do that. P or Q. This is where we have basically to memorize this stuff. P or Q, we know what's P or Q is false. Only when both are false is true everywhere else. P and Q. Again, we know that. P and Q is true when both are true. It's false everywhere else. Now, what's not P and Q? Not P and Q is the statement which is true whenever P and Q is false. False whenever P and Q is true. That's important. So this is P and Q. The negation is false. It's true every time P and Q is false. Now my last step is I need to take this one and this one. And then I want to take the and between them. So these are now, so I did the pieces, and now I need to combine them by in and. So what do I get here? P or Q and not P and Q. True, false. The and is false. It means if both are true, this is false. Now, true, true, true. Means if one of them is true, this is true. Now here, true, false. It's false, true. And this is true, this is true. That's true. False, true. That's in and. What am I doing? This is false. Okay, so let us watch this table. What does this tell me? P or Q and non-P is false when both are true, false when both are false. It's true in one case, when one is true and the other one is false. So this is basically the same thing, if you want. I'm going to talk about that again. The same thing as the exclusive OR. This is the same thing as the exclusive OR, because the exclusive OR is true only if one of them is true. It's false other place. Okay. So let us draw the truth table of some truth table, and then we go back to the idea of what is this thing. Okay. So let us practice a little bit truth table. I'll give you two easy ones first because I want your intuition, and then we do them. Suppose I want you to draw the truth table of P or non-P. Okay. Before I do the truth table, what do you think is going to happen?
Shouldn't it always be true just because it will, since it's or, it's just going to flip?
Exactly. It's going to be always true. Because take any simple, anything. If I tell you X is 0 or X is not 0, That's always true, whether you know X or you don't know X. Either it's 0 or not 0, that's my statement is always true, even if you don't even know X. Because non-P is not P. So either statement is P or is not P. Okay, the truth table will actually show it to us immediately, that what we're saying is correct. That's P non-P, those are the component, and this is the one I'm interested in. All right, so P, I have only one, is either true or false. Non-P is gonna be false here, true here. So what's P or non-P? It's true and false. This is gonna have to be true because that's the or, and this is gonna be true. So P or non-P, this is always true. Okay, and there is a name. If you have a statement and it's always true, we give it a name and we call it anybody know what we call it?
Tautology?
Yeah. I think I spelled it correctly. Tautology is a statement that is always true. That is always true. So that's we called a tautology. P or non-P is actually a tautology because regardless what P is, this is always a true statement. All right. Now let us have the truth table of something that has more than 2 components because we have to know them. So suppose now I have 3 statements, P, Q, and R, and I want you to just draw the truth table of. So the goal of this problem is mainly to practice how we sketch truth table of P or Q. Parentheses are crucial. We can't really move parentheses, and R. Okay, P or Q and R. All right. How do we draw the truth table of that? It means we have to draw a table that tells me what's the truth value of an expression like this, regardless of what P, for all possible value of P, Q, and R. Now, before we do that, how many possible value we have? So I'll do it once and I guess will become clear. P always is true or false. So before I draw the truth table, let's see what is going to happen. For every value of P, Q would be true or false, true or false. Okay, so how many entries this is going to have? R, true or false, so for every possible, true, false, again, true, false, true, false. So how many possible scenario or possible values we're going to have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to have 8 different possibility of values for P, Q, and R. So when we draw the truth table, we're going to have all of those. So most probably that's one of the last time I draw a table like this, but we have to do it at least once. So you guys do it also in your homework. So P, Q, and R. Okay, so let's see how we're going to write the possibilities. All right, P could be true, and everything P is true. Q could be basically true or false, but whenever P is true, R could be true and false. That's really the logic we're going about it. So this is true, this is true. If this is false, R could be true and false. So we're gonna have, we write it this way. So this is grasp, this is capture all the possibility P could be true. And then if P is false, also we have 4 other possibility. If P is false, Q could be true, but if Q is true, R could have 2 different scenarios. And if P is false, Q could be false, but R could be either false or true. So this is all the possible scenario of P, Q, and R. So now what's the truth table of P or Q and R. As I said, we do it piece by piece. I do that, and then I combine. So P or Q. All right, that's the possibility. P or Q, that's true, true, false, true, false, false. It's really nothing really hard here. Sorry, it's it or. That's it true. False, true, that's it true. False, true, that's it true. I did a mistake. True, 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 false. My apology. Is it true? And then false, false. That's when it is false, 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 when it is false. Okay, I stop in case I'm going fast. Okay, and then I have R. I already have R. And then I have to combine them. So the last piece is, so I have the pieces. I have this, I have that. So the last piece is actually to combine them. P or Q and R. Now I combine both of them, so I have to focus on those two. And there is an AND. And we should know the AND. If both are true, the AND is true. One is false, this is false. Okay, this way. Both are true, my AND is true. One false, my AND is false. Both are true, my AND is true. So it's tedious, nothing deeper than that. One is true, my AND is false. Sorry, one is false. One is false, my AND is false. And so 1, 2, 3, 4, 5, 6, 7. And the last one will have to be false. So that's really the truth table of P or Q and R. It means it's a table that tells me regardless, if I just look at it, okay, what happened if T is P in this scenario? So I can know exactly that this is true. Okay, so drawing truth tables is actually not hard. It's just tedious, nothing more than that. Now, why we use them? Right? Okay, so now why we use them is because of what we said at the beginning. One of the things we use truth table is logically, if I write the statement in two different ways, what does it mean that both ways are the same? To say that both ways are the same means that every P and Q that make the first true will make this true. Everything that make this false will make this false. So we're going to define the notion of logically equivalent. Two statements are logically equivalent if basically they have the same truth table. It means if everything that makes one true will make the other, every possible of P value of P and Q that make this one false will make the other one false. Because in math, usually whenever we introduce an idea, like we introduce the idea of a set, I need to tell you what does it mean for two sets to be equal. So we have to give meaning of what does it mean those two objects to be the same. For set, we said two objects are the same if they have the same element. When we work in math with functions, we say, okay, what does it mean two functions to be equal? I mean, that's kind of one of the definition. If every input here equal to every input here. So whenever we introduce a new mathematical idea, we have to say, what does it mean for two to be the same? And this is what the idea of logically equivalent is about. So two statements are said to be logically equivalent if they have the same truth table. So let us work with that. Okay. Give me 1 second and let's start. So logical equivalence. Two compound statements, it means statement obtained by combining other statements, are said to be logically equivalent if they have the same truth table. So let us take some examples and proceed. So suppose I'll start with an easy one. I want you to show that, suppose P is a statement, show that the negation of the negation is logically equivalent to P. Now, usually there is books differ at this notation. This means logically equivalent, meaning they have the same truth table. Okay, so now what am I telling you? Show that the negation of a statement is the statement itself. Does it make sense? It's not true that today is not Wednesday. It's like today is Wednesday. So let us say that these are the same. So let's draw the truth table of those. Since I have one statement, it has two values, true or false. To show that those are equal, I have to show that the truth table of this and the truth table of that are the same. It means whenever this is true, this is true. Whenever this is false, this is false. So what is the non-P? Non-P is the statement which is false when this is true, true when this is false. So non-P is the negation of that, true and false. So this is P, and this is not P. Those are basically the same statement. So for example, if I say it is not true, okay, if you ever somebody tell you the following, it's not true that today is not something really messed up statement, is not Tuesday, not Wednesday, for example. It's not true. So we're negating that today is not Wednesday. Basically, this nothing more than today is Wednesday. Okay. And here my P is the statement today is Wednesday. That's how I'm thinking about it. So that's my P. It's not true that today is not Wednesday, but it's not the case that not P. P is Wednesday, not P. It's not Wednesday. And this read, it's not the case that it's not P. This is basically telling you it is P. So the negation of the negation is actually the statement itself. Right. Let's see another one. Another truth table. Let's see which one I want. Okay. Let us say that that's called the distributivity property. Distributivity property. It tells me the following, that if you take P or Q and R, this is logically equivalent to take P and R or Q and R. So those two statements are really the same. All right, so what does it mean to be the same? It means the truth table of the first equal to the truth table of the second. So how can I show it? I draw the truth table of that. I draw the truth table of this, and I show they are the same. Now we already drew the truth table of P or Q and R. To show that those are logically equivalent, I have to draw the truth table of this one and then show that they take the same exact same value. So let's do that a little bit. I will copy one. I want to repeat it, and then I figure out the second one, which will be a second way to practice those tables. All right, so P can take 4 values. So that's the last one I do because these are false, false, true, true, false, false. And what is R? R does what? It's true, false, true, false, true, false, true, false. Now P or Q and R, I will pick up the one we did. I will not do it again. And this was true, granting I didn't do mistakes over there. This one was false, of course, because R is false. This one is true for sure. This one is false because R is false. This one is true. This one is false. And this one is false because, and this one is false. Now I do the last one, P and R or Q and R. Now to be able to do that, I need the pieces. So we do P and R by itself. I do Q and R. And then I do the one that I want, which is that. Parentheses. Crucial, without parentheses, things will not be logically equivalent, as simple as that. So now let's do P and R. So I have to focus on those. So that's it true. That's it false because it's in AND. That's it true. And so that's a good practice of all those truth tables. That's a false. That's a false. That's a false. You guys correct me if I am. That's a false because that's in AND. And that's a false because it's in AND. Am I going fast for you guys? Please let me know. Put on chat if it's fast or not. All right, Q and R. True. That's definitely false because it's in AND. That's a false because it's in AND. That's a false because it's in AND. That's a true. That's a false because that is in AND. That's a false. And that's a false. And now finally, the OR. And that will do it for us. So the OR, that's an OR. So that's a true. That has to be false. That's an OR, that's a true. This has to be false. That's an OR, so that's a true. This has to be false. This is false. And this is false. And this would give me the following. Tells me that I compare now those two columns, this column and that column. And definitely I have the same truth table because F, 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 T, F, T, F, T. They have the same truth table. It means those statements are logically the same. P and R or Q and R. Okay, those are logically the same thing. So suppose I write the following. Suppose I write the following for you. I tell you something like the square root of 2 is in R. That's one sentence. Or the square root of 2 is in the set of all rational numbers. And square root of 2 is in Z. Suppose I write the statement. Okay, so is this true or false?
True.
The true or false?
The first part's true.
The whole thing. The whole thing. Is it
The
true
whole
or
thing's false because you have to have and in the integer numbers.
Exactly. This tells me that this is the same thing as telling Q. The square root is in R and in Z, or it is in Q and in Z. Those two statements logically will mean the same. If this is false, this will have to be false. If this is true, this will have to be true. Now let us study the second one. Is this, if this, it has to be false, but let's make sure. That's false because this doesn't hold and there is an and. This is false because this doesn't hold and there is an and. All right. The last thing I will do is the following question. I will address it to you and next time we will take it from there. My question is the following, very simple. If I take two statements, P and Q, okay? So P and Q, and we negate them. same thing as negating P and Q. So suppose I tell you the following. John, I don't know who John is, but whatever, John, is it John? Is tall and he is, let us say, he's tall and give me another nice property of a person. Any other property. And speaks French. That's nice. Okay, that's my statement. So my statement is that John is tall and speaks French. And I tell you, negate this. What does it mean to negate? To negate, it means, how can this statement be false? So negation is a statement which is true exactly when my original statement is false. You know, my question to you, what do you think is the negation of that? How can the statement, John is tall and speaks French, be false?
He's short and doesn't speak French.
He's short.
No, is not tall and doesn't speak French.
Or
Doesn't speak French. So it means the way you are negating it is that you're telling me that to negate P and Q is the negation of P and the negation of Q, right?
it's or.
Let's see. Yeah. Now let us judge that by doing something mathematical. Question number 1, are those two the same? And then we discuss why your classmate is not right. First, are those two logically equivalent? It means the negation of P and Q the same as the negation of P and the negation of Q. Okay, let's do the truth table of both of them. So that's a P and that's a Q. And the question is, are they? All right, that's P and Q. And that's the negation of P and Q. So I'm gonna do the first one, then I'll do the second. P is true, true, false, false, true, false, true, false. P and Q is true only in this scenario. Everywhere else is false. So what is the negation? The negation is a statement which is true and the original one is false, and the other way around. So my negation is going to be false here. My negation is going to be true everywhere. So when is the negation of P and Q true? Here, here, and here. All right, so now let's take non-P and non-Q. Let's do that. All right. I should have done non-P, non-Q, but that's okay. Okay, if P is true and Q true, what can we say about non-P and non-Q? True or false? Quickly.
They're both false.
So that's false. In this scenario, if P is true, Q is false. What can we say about
It's
non-P and non-Q?
False and then true.
False or true?
False, false, true.
False, false. Because non-P is false. So I don't care. The end is false. What about here?
False.
False. Because Q is true. Non-Q is immediately false. And what about here?
True.
True. Are those two
No,
the same?
they're not.
Absolutely not. So the negation of P and Q is definitely not the negation of P and the negation of Q. All right, now we'll talk about what it is. Now I want one question from you, one example. I want you to give me a real example, a mathematical example, not a John is tall, a mathematical example of P and Q, such that the negation of P and Q is true, non-P and non-Q. No, sorry. I want this one to be true, and I want this one to be false. Okay, I want an example. I want it mathematical in nature, something that we all agree. We don't have any. So I want a situation where one is true and one is false. So this tells you that, you know, negation is very problematic, and that's what we're going to be talking about it next time. Okay, give me an example before we go on. Before we stop, sorry. I want a P. I want a Q. Make this true and this false. And the truth table should actually give it away for you. Whoever has an idea, let me know.
So looking at the truth table, you would want like a P would be a true statement and Q would be a false statement.
Very good. Give it to me immediately.
Could it just be like today is Wednesday?
Let's take something. Let's take a mathematical statement. So there will be no question asked.
P2 is even.
2 is even.
And Q 100 is odd.
100 is odd. Okay. Now P and Q. 2 is even. That's correct. 100 is odd. That's a false statement. It means the negation is true. However, non-P and non-Q is what? Now, P is true, it means this is false. This is a false statement. Okay, so the negation of P and Q is definitely not non-P and non-Q. Okay, so I want you to think a little bit about it for next time. And then we take it from there. We start what we have next time. We're going to focus a little bit on negating. How do we negate actually statements? And the truth table will help us negate them properly. Okay.
Before we close the meeting, can you go back to the example with the square root of 2 and just I just need the last line of it. Yeah, that. Give me one moment.
Definitely. Please let me know when I'm going fast because I don't.
Yeah, I just want to make sure I have all the.
I don't see your faces.
Right.
It's so hard for me.
I just want to make sure all my
Absolutely.
symbols are correct.
Yep.
Okay, I'm good. Thank you.
Okay. Have a nice Labor Day weekend and see you next Wednesday. Please make sure you do the homework. I mean, it's due, you have the due date, but please make sure to do it. It's not hard, so things will not accumulate. And I will always give you like practice problems just to, you know, to help you keep up with the lecture. Okay. Bye-bye for guys. Bye now.